All right, let's now continue our discussion about generics in Java. Let's recall very briefly about what we discussed last week, just to connect more smoothly to this week. So we talked about the so-called general book, where we got an attributes of type, an array of objects, which will make the storage very flexible. We can basically store anything into the array because every class is actually a descending class of objects in Java. However, on the other hand, for the retrieval from the book, it's actually quite limited because we actually have to do lots of instance of checks and also typecasting, which will severely violate the single choice principle. You should really review how this design principle of single choice is really violated. That's the main point that we tried to convey to you last week. And we actually concluded by saying that we need a solution which will definitely help us eliminate the occurrences of all the class cast exception. However, the way to do that, the way to really eliminate all the class cast exception should not be through the explicit instance of checks and also typecasts, because we know that you will violate the single choice design principle. So that's kind of the constraints we have on ourselves. But we definitely have a solution for solve that ideally. And we talk about the sketch, about the solution. Let's now review very quickly. First of all, we want to say whenever you try to declare a book, you want the user to actually commit to what kind of objects you want to store in the book. If you want to store the dates, you store dates only. If you want to store the string, you want to store the string only. You don't want to have a mix. Right? So that's kind of the idea for the first criterion. And the second one, whenever you once you commit to the kind of objects you want to store in the book at the declaration time, you want to make sure every time you want to store some new record into the book, you don't want to be as flexible as what's in the general book. You want to say if the static type that you're trying to store into is not really a descendant class of the type you actually committed to when you declare the book objects. In that case, you don't want to allow the insertion or the addition to actually compile. Okay, and number three, so that should be a compilation error. And number three, whenever you're attempting to retrieve a record, which is what we suffered in the case of the general book, you want to make sure whenever you want to retrieve, you will be able to assume a little bit more on the retrieve objects. So this is something that we'll see exactly how the ideal solution can help us. All right, so that's about the very quick brush up from last week. You want to make sure you really understand the issue why the general book is not really the way to go. And this is why we want to introduce to you the new solution, which is about using generics. Let's now go into it. All right, we spoke about the ideas about parameters. Okay, you can review it. Let's now start directly about how to do generics. Okay, let me switch to iPad and let's now discuss the syntax for generics. All right, so I want you to focus on only this fragment for now. Okay, so when I say supplier, I meant the implementer for the generic classes. Right, we'll see one example first, and then we'll see some other examples in the Java collection library, which I assume you already studied in the first year. But let's go one at a time. Let's now see how we can declare the class for a generic class. We say class, of course you can put public if you wish. So we say public class and then the name of the class, and this is some new syntax for you to learn. Okay, you can see this is some angle brackets followed by another matching angle bracket, right? And inside we actually put some name, and this is so-called type parameter, right? Let me annotate it, and I'll draw some analogy about what exactly what you do in the Java methods. It's so the idea is really not that new, but the syntax is a little bit creative for you. Okay, you can see this part over here, the E. Okay, so this is so-called the type parameter. And what is the purpose of declaring a parameter? Well, like the case for methods, the reason that you want to declare a parameter is actually for arguments to be passed when you actually want to call the method, right? So now in the case of a type parameter, the reason that you want to declare this type parameter is for some arguments or for some instance to be passed in order to instantiate what this E is. That's something we'll see. Okay, and so this is a type parameter. Once you have done that, you can think about this part over here is the scope of the type parameter, the entire class. Okay, let me just also annotate it. So you can think about this part over here is really the scope, the entire class, the scope of the type parameter, i.e. entire class. You will be able to refer to the E whenever you need to. Whenever you need to declare the type, maybe for return type, maybe for attributes, maybe for a parameter, you can simply use the E. Okay. Let me just say a little bit more. So the scope of the type parameter, right? So when I say the scope, which means you can use it, use E for at least 3 purposes: attribute type, and maybe some method parameter type. And also number 3, method return type. Okay, the font is a little bit small. Hopefully you can still follow that. Okay, let's see exactly how we did it, right? Well, exactly, we got 3 cases over here. Let's see the first one about attribute type, right? For attribute type, you can see we're using E over here. E is the element type for this particular array, right? We got a primitive array, and we say that every element in the array should have the static type E. So here, the E is really using the E over here. Okay, let me just use this color over here. Okay, so this E. So this is the attribute type. Okay, similarly, we can also use that to declare parameter type, right? So that's the second purpose I just mentioned. So let's say, what about method parameter type? So this will be the one example. Okay, you can see here we are also using the E in place of some type, right? Typically, you might just say object, you might say string, or you may say person, and etc. But now we are simply just saying E. Okay, so this is the method parameter type. Right? So that's the second usage. Let's see the third usage. The third usage is about method return type. Okay, this is one such example. You can see we just replace every occurrence of objects compared with, in the case of the general book, by the type parameter E. That's what we're doing. Okay, so this one is the method return type. Okay, I want to draw some analogy to you right away, right? Hopefully that can also help you understanding. But so far it's been hopefully straightforward. Let's now consider some Java method, right? Let's say we have a method over here. Let's say just a mutator, right? Just for simplicity. Void and also m. Let's say we have some parameter, let's say integer, let's say x over here. Okay, and over here we can simply say in the method body, right, we can definitely refer to the x in order to implement whatever algorithm we decide to actually use for the implementation. So let's assume we actually got some attribute z. We can say this dot z is actually assigned to maybe this dot z multiplied by x, right, just for illustration, right? So now I want you to draw the following analogy over here. This is the declaration of the parameter, and this is the usage of the parameter in order to define the solution. It's very analogous to, you can see this is the declaration of the parameter for the type. And these 3 occurrences are the usages for the type parameter for declaring types, right? So that's really the analogy I would like you to see. Okay, let me write it down. Okay. So the x over here is the declaration of the parameter. So this is the declaration of parameter. Okay, and this part over here, the x, so this part over here is the usage of the parameter. Again, this declaration over here is analogous to this declaration over here. And this instance of using the parameter is analogous to these 3 instances of using this parameter over here. Okay, let me just say one more thing. Okay, so this E over here is really using this parameter this E over here is also using this parameter, and this E over here is also using this parameter, right? Uses. Okay, and the only difference is here when I'm using the parameter X, I'm trying to use that in part of the arithmetic calculation. And over here, when we are using this parameter over here, in here, or here, we're using that for the purpose of type declaration. Okay, let me just say a little bit more. Okay, uses. Oh, actually, let me fix my eraser. All right. So you can say uses for type declaration. It's very important for you to understand conceptually how the type parameter actually should be declared and also used. Very important. Okay, uses for type declaration. All right, and that's about the from the supplier side, from the implementer. Let's see exactly how to use this. Okay, so now you can take a look at this fragment of code. It's very similar to the example code which we spoke about. Let me just show to you over here. You can see this part here. So this part here is about the test code for the general book, where you can see we didn't have any type parameter. We just got objects over here, right? For the attribute type, method parameter type, and also method return type. That's in the case of general book. But now, given that we got a generic book over here, we got a generic book using a generic parameter for type. How is the test code going to look differently, right? And the point I'm going to illustrate right now is going to correspond to the 3 criteria that I just recall together with you, right? You can see it's going to be criteria number 1, criteria number 2, and also criteria number 3. So that's what we're going to see, okay? Just to remind you. All right, let's now take a look at line by line quickly. Still, we got declaration for the birthday. We got declaration for the phone number, right? Just remember there are different types of objects. And here, this part is really important, right? So you can think about this test code is really the code by the clients or like a user. The user is trying to test the generic book. And this part over here is this part here. So when we got book and B over here, and specifically, I want you to look at the dates over here, right? Oh, by the way, you can see whenever you want to use a generic class, when you declare generic class, you have to use a pair of angle brackets. And when you actually want to use it, you also want to surround the actual type by the angle brackets as well. Okay, that's something I want to note to you syntactically. And especially for the dates over here inside, right? So this dates is really going to instantiate E. Instantiates the E over here. You can see the E here. You're going to instantiate it by dates. And some quick analogy. Remember we talk about this method over here, right? So whenever you want to call, let's say some objects, some context objects.m, and then I might simply just pass 23, right? You can think about the 23 over here is like the dates over here. We're just passing some specific value that is going to be used to instantiate a parameter. So here in this case, we're using 23 to instantiate x, the parameter. And over here, we're using some concrete type called dates to instantiate E. And what's the consequence of this? The consequence is, let me just use a fresh copy over here just to show to you. Okay, so let me copy this. Right, just remember we got only a single copy of the definition, but now you can think conceptually. What Java compiler is going to do is to create separately behind the scene another copy of the book declaration, like over here. Okay, and this one over here is going to do the following. Since the user tries to commit that the E is going to be instantiated by dates, so that means this part over here is going to be instantiated by dates. Not only that, every occurrence of E is actually going to be replaced by the dates. Date over here, dates over here, and dates over here. So that means the B over here will be as if the following declaration. We simply declare every member of the array has a static type dates. And every time you want to call this mutator at, the second parameter over here is dates, meaning that any arguments, because of call by value, right? Any arguments should be a descendant class of dates, including date itself, right? We talk about polymorphic method parameter. And every call to the get method, accessor method, is going to return some descendant type of dates as well. So you really want to know the consequence of committing to the dates over here, which will replace every occurrence of E over here by the dates, right? That's really important for you to actually understand this part over here, right? Let me just highlight it. And then I'm going to just make some notes over here. So this part here is the consequence of declaring book, and then angle brackets, we're instantiating the E by a concrete type called dates. Okay, it's really important for you to know that, right? That's a consequence. Okay, let's now move on. So now if you want to answer any questions related to B, you have to imagine this particular behind the scene copy of the book, right? Where every occurrence of E has been replaced by the dates, which corresponds to the dates over here. All right, and how do you actually instantiate? How do you actually create a new object? You simply say B is assigned to a new book, and then you just give the same dates. You can think about this date here must match the dates over here. But in Java, you should really try it out yourself. You can even omit this part over here, the dates. If you omit it, Java compiler will also be able to figure out exactly what you meant over here, right? Because you already commit to it the dates over here. All right, and then we got phone number as before. We got phone number and also we got birthday. And I want you to now think about line number 5, line number 7, and also line number 8. Will these 3 lines compile? And let's recall very quickly in the case of general book, right? If you go back to the general book example over here, line number 5 and line number 7 are to do with storage. And both of them will just compile because we are expecting some objects, and every argument objects will definitely be a descendant objects of what will definitely be a descendant class of objects, because any class will be a descendant of objects in Java. So that's why line number 5 and line number 7 in the case of general book will just compile. But line number 8 is about retrieval. In the case of retrieval, the best you can assume from b.get, it's about its static return type, which is objects. So that's why you cannot invoke get dates on that, right? That's what we said last week. But let's now see, given that we got this behind the scene copy instantiated already that the Java compiler is going to use. So now what's going to be the consequence to checking the validity of line number 5, line number 7, and line number 8? All right, you can pause the video and think about it. All right. Assuming that you thought about it, let's now take a look one by one. For line number 5, okay, let's take a look. Suyang over here, we gotta check against the behind the scene copy, right? The consequential copy. Suyang is going to match the string over here for add, right? That's okay. What about phone number? Phone number is actually over here. Phone number was declared to be a string. So now we got polymorphic call by value, right? We got polymorphic method parameter. So this is dates over here. That's the parameter, and this is the arguments, right? So now let me just try to do a little bit of illustration over here. So for call by value is going to do the following assignments, right? It's going to be the parameter record is assigned to the arguments phone number. Okay, phone number. Okay, is this call by value going to work for this particular method call? The answer is no, because phone number has the static type. So phone number over here has the static type string, right? As you can see here, the string. And what about record? Record is this instantiated parameter type because of this line right over here. So that one should be dates. That one, the static type is actually dates. And the question we know we should ask in order for this line to be valid is string a descending class of dates? The answer is no. So that's why this line is not going to compile. All right. Right. So line number 5 is not going to compile. Okay, not compiling. In some way, this is very good news because since we actually commit at the time of declaration, we commit that every element in the book, in the generic book, should be a dates, which means E is going to be instantiated by dates, and every occurrence of E is going to be instantiated by date specifically, right? And in particular, the records array internally, every element is going to be of type dates. So now if you're trying to store a string into it, it should not be allowed. So that's why it should be a compilation error. All right. What about line number 7? It will be a very similar argument, but now you can see it's birthday over here. So we know that birthday over here, the argument static type is actually dates. Right? It's a static type is actually dates. So now, let me just draw a little bit better. The dates over here. So now the question is dates a descending class of the parameter static type dates? Indeed, it is. So this line is actually okay. So this line is actually check. It's going to compile. What about line number 8 over here? Right? Let's now take a look. So b.get UNA. So in this case, the argument value UNA here is not really that important, but we have to look at the static type for b.get. B.get is going to invoke this version of the method behind the scene, and we know that statically its return type is actually dates, right? Corresponding to the dates over here. So its static type over here is actually going to be the dates. And now, if you try to invoke getDay on the dates class, it will be okay, right? So this is okay. Check. It's really important for you to really compare and contrast why the storage line over here, one of them is not going to compile, whereas in the case of general book, both storage line will actually compile. One thing. The other thing, in the case of the general book, when you try to retrieve some objects from the book, the static type is always just an object. So that's why without a cast, you just cannot invoke any like a record specific method on that. In this case, the date method. On the other hand, in the case of the generic book, since we already commit that every element in the every record in the book is going to be of type dates. Specifically, we're going to instantiate the E over here by dates. So that means b.get over here is going to correspond to this static type over here, right? That's behind the scene. So that's why getDay can actually be invoked. All right, so that's about a very detailed walkthrough of the generic classes. This part over here is about how you declare the generic classes, how you implement it. And this part over here is about how you declare it and also how you use it by calling different methods from the generic classes. And the most crucial work for you to actually do in order to do the reasoning is to really figure out this behind the scene copy of the generic classes, especially after we have declared this type over here, how you can actually replace every occurrence of the generic type parameter by the instantiated type. All right, so that's about what I want to discuss for this example here. We'll see more in just a moment. Okay, let me go back, and you can see, okay, let me just go back to the generic Java generics over here. So that's a class declaration. Again, you want to watch out for the angle brackets over here, right? Left angle brackets, and also right angle brackets over here. And you also want to remind yourself about the analogy to Java methods over here, okay? And that one is the example code. And this slide here about explanation was exactly discussed just in the iPad, right? So I can now move on. Okay, and let's now take a look at 2 more examples about using generic classes by considering what you learned from the first year, namely array list and also hash table.